Ever wanted to enhance the reliability of your Mikrotik network? Well, today we are diving into the world of VRRP, the secret ingredient for building ultra-reliable networks. Ready to give your network a boost of resilience? Let's jump right in. Welcome to the network trip. Hello and welcome. Today we are going to be diving into the world of VRRP. So what exactly is that protocol? So Virtual Router Redundancy Protocol. So this is a standard. So that means that we can have a Mikrotik device working together with a device coming from any other vendor. But in the video, I'm going to be using only Mikrotik devices. So what exactly are we trying to accomplish with this protocol? So we're not using a dynamic routing protocol like OSPF or BGP. Then we're going to have a network that is going to be something like this. So we can see that we have some users that are connected here. Those users are connected to that switch. That can be a dedicated switch, or that can also be a bridge that is going to be created in the router. So the idea that those users are pointing to the router. So basically the router is the gateway that will provide access to remote networks. So the main issue here is that if this router is going down, then those users will be disconnected. They won't be able to talk to remote networks, like for example, browsing on internet, sending traffic or receiving traffic from internet. How can we enhance that network topology? And basically the idea is to use VRRP. That basically is adding a second router, and we're going to create what is called a virtual router. And now, instead of having just one router, we're going to have two of them. And the clients underneath, instead of being pointing to a physical device, they will be pointing to a virtual router. So how that virtual router is going to come up, that's basically what VRRP is going to be doing. So the router will be sending some messages. And they will agree about the master, who is going to be forwarding traffic, who is going to be in a backup state, and basically that master device is going down, then those devices will dynamically leave out of the second device. But we don't need to change the gateway because they will be pointing to a virtual router. So that's the main idea behind VRRP. So we're going to talk about some technical details. So VRRP is going to be using the IP protocol number 112. All the messages that are exchanged between the routers to be able to create a virtual router will be sent to a multicast address. And for IPv4, that is 224.0.0.18. And for IPv6, it's going to be FF02::12. So that means that we can have VRRP running for IPv4 networks, for IPv6 networks, or both. Every message is going to have a TTL with a value of 255. But if a router for any reason is receiving a message with a lower value, then it's simply going to drop that packet. So they will be exchanging messages with some values in it. And basically that TTL is going to be 255. If this device here is getting a value like 254 or something different, probably someone is trying to harm our network. And then this device is simply going to drop that message. Additionally, after having VRRP running, we're going to have a virtual router. And basically that device, that virtual device, is going to be the gateway where those users will be sending the traffic to. So that virtual router is also going to have a MAC address. And that MAC address is going to have that format. So we're going to have 000005E, 0001, and then the last octet is going to be configured according to the virtual router identifier. So that means that we're going to set an ID for the router. This is simply going to be a number. And we can have multiple virtual routers in the same broadcast domain. So for example, the virtual router is 100. So we're going to configure the same ID in those two devices, and they will agree about which virtual router is going to be used for a specific network. But we can have as many virtual routers as we want, and we are simply going to identify them with a different number. But who is going to be the master device? So basically that is going to be defined based on a value that is a priority value. By default, the priority is 100, and then the device that we want to have as the master is simply going to have a higher priority. So the maximum value that we can have is 255. So if we analyze this diagram, so you can see here that we have a switch where basically all our users are connected, and then the local area network interface for those two routers that will be participating on VRRP are going to have an IP address on the physical interface. That IP address is going to be different. For example, here we have 10.1.2.1, and for the second device we have 10.1.2.2. So they will be in the same subnet, but they will be different IP addresses. And then we're going to create that virtual interface that is going to generate that virtual router. And then that virtual router is also going to have an IP address. We are able to use one of the IPs in those physical interfaces as the IP of the virtual router. If, for example, we are setting the IP 10.1.2.1 to that virtual router, and R1 is the master, so that device is going to be called the owner, because the virtual IP is going to be equal to the physical IP. But we can have a different IP value. For example, I can set here the 10.1.2.254, and that's completely fine, but the virtual router must have the same IP in both physical routers. So now we need to think about what exactly is going to happen when the master device is going down. So let's think, for example, that this router here on the left is going to be the master. So probably PC1 is sending some traffic. So traffic is going to come here, then it's going to go to router 1, and then it's going to leave. So let's say there is a session on internet, probably there is a ping that is being sent to 8.8.8.8 or any other type of connection going from that device to a remote network. So we know that those routers will keep track of every conversation in what is called the connection tracking. If this device is going down and now R2 is taking over, so that means that the traffic is going to leave out of that way. But if this device has a session already established, then it's going to have some issues because that conversation is not going to exist on R2. So that's why we are able to enable connection tracking synchronization. Basically, this means that the master device, the one that is actually forwarding the traffic, is going to be sending copies of the connection tracking to that backup device. And now, if for any reason the device has a failure and is going down, the traffic is going to leave out of R2, and R2 will already know about all the established connections. And basically, to enable this feature, we simply need to check a box in that VRRP configuration, as we're going to see next on the lab. Enough theory, now let's jump into the lab. So now we are going to have here two routers. So we have R1 and R2. Those two routers are connected to a switch. And basically that switch is going to be facing end users. So to simulate that, I have two PCs, PC1 and PC2. So the idea now is that we are going to create a virtual router by using this protocol VRRP. And that virtual router is going to have an IP address that is going to be 10.1.2.254. And basically the gateway that those devices will be using is the IP in that virtual router. Additionally, the LAN interface in every router is going to have an IP from the same subnet. So one is going to be 10.1.2.1/24, and the second router is going to be 10.1.2.2. You can see that we don't have any physical link between the routers because they are connected to the same switch, and the messages that VRRP is going to generate will go through the switch and then will be reaching that device on the other end. So the idea is that R1 is going to be the master device and R2 is going to be the backup. So to be able to manipulate that, we are going to use the priority value. So the priority value in R1 is going to be 200, for R2 is going to be 100. So the higher value, the better. Additionally, this virtual router is going to have an identifier that is going to be 100. And we're going to set the same value in both routers. You can see that at this point, I also have a connection to internet. Basically, this here is my office router, and I'm providing an IP via DHCP. So there is a different IP address on Ether 1 for R1 and Ether 1 for R2. And also I'm using NAT. So we're going to start by configuring this device. So we're going to go to R1. So let's see what I have now in that device. So we can see here, if I go to IP addresses, so currently I have the local area network IP that basically is 10.1.2.1. I have the connection to the WAN interface. There is a default route that basically is pointing to my office router. So we can see that this device has a NAT rule that basically is masquerading all the traffic that is going from the LAN to internet. So if I open this rule, all the traffic leaving out of Ether 1 is going to be masquerade with the IP that is on Ether 1. So basically at this point, this is just the regular configuration that we have commonly in our local area networks. So how are we going to work with VRRP? So the process is going to be pretty straightforward. So the step number one is that we need to create the VRRP interface. The second step is to add an IP to the physical interface. In my current topology, I already have those IPs on those physical interfaces. So basically, we simply need to create the VRRP interface with all the parameters, and then we are going to add the IP to the virtual interface that basically is going to be the IP in that virtual router. So let's see how to perform that configuration on R1. So we are going to go here to interfaces, and then we go to the menu. We are going to find here VRRP. So you can see that we have a tab for VRRP. So we simply need to add a new entry. So let's call this VRRP-LAN. And then if we go to the second tab, we're going to have here the interface. So this is going to be on Ether 2. So we're going to select Ether 2. Then we need to pick the virtual router identifier. So according to the diagram, this is going to be 100. The next option that we can configure is authentication. So authentication is available only for version 2. If we're going to be using version 3, the authentication is not possible. So now I'm going to be using version 3, and we're going to be using IPv4. You can see that you can also be running this for IPv6. If you need to run both protocols, you will need two different virtual interfaces. So this is everything that we need on this tab. So the next one is the connection tracking. If we want to have the master synchronizing all the information, sending copies for every entry in the connection tracking to the backup, so we're going to enable that feature just by clicking in that option here. And now I can simply click OK. And you can see that I'm getting a warning message telling me no IPv4 address on that interface. According to the diagram, that IP is going to be 10.1.2.254/32. So you can see that this is a single IP address, no /24. So I will come here, IP addresses, and I will add an IP, and this is going to be 10.1.2.254. And this is going to be on the VRRP LAN interface. So now it's on seconds that VRRP interface is going to be up. Now we only have one device that is connected. So you can see that now that is black. That interface is running. If I go to interfaces, we're going to see for that interface that we have RM here under the flags column. R for running, M for master. So basically it's telling this is the master device. So now on R2, we're going to go through the same steps. So the first step is going to interfaces. Then we're going to go to the VRRP menu. And then we are going to add a new entry. So it's going to be VRRP-LAN. So the name is completely up to you. And then we're going to jump to the second tab. And then here we are going to use the Ether 3 interface because that's the interface that is connected to the LAN switch. And then I will select Ether 3. The virtual router identifier must match the value that we have on the other device, that is 100. And then for the priority, we have 100, so that means that this device is going to be the backup because the other one has a priority with a greater value, that is 200. So I'm going to keep 100. We are not using authentication version 3. And then if we go to connection tracking, we don't need to enable that feature here because this is going to be acting as the backup, and we only have 2 routers in this setup. If you have more than 2 routers, let's say you have 3 routers, for example, then you can set that connection tracking option in the router in between with a medium priority, because eventually the router can be the master and still needs to push those connection tracking entries to the backup device. But in this case, there are only 2 routers, so we actually don't need to enable this feature here. So now you can simply click OK. Now there is no IP address on that VRRP LAN interface. I'm going to add a new IP, and the IP is going to be the same IP that we have set in the virtual router on R1. So the IPs on the virtual interfaces must be the same. And also they will be a single IP, no /24, no mask. So it's going to be a /32 IP address. And now I can simply click OK. Those devices will exchange some messages, but R2 is going to know that R1 has better priority, and then R1 is going to remain as the master device. So now if we go to those PCs, we can simply set an IP address. So for example, 10.1.2.100/24, but the gateway now, instead of pointing to those IP on the physical interface, it will be pointing to the virtual IP in that virtual router. So you can see, if I send a ping to 10.1.2.254, so you can see that that PC is able to talk to that virtual router. So from the perspective of that PC, there is just one router, and that is a virtual router. If I show the ARP table, so you will see here the MAC address. So we can see everything that we saw before, and then here we have the number for that virtual router identifier. So the number is 100, that is equivalent to 64 in hexadecimal. That's why we are getting that MAC address. And if I send a ping to Google's DNS server, you can see that we have reachability. If I trace that traffic, so you can see that the router that actually is replying is R1. So we can see that here by checking the first hop, that is 10.1.2.1. So now the traffic is flowing out of R1. So I'm going to keep a ping running. And now I will come to R1, system, shutdown, yes. And now R1 is gone. So you can see that we are getting some timeouts, and now that ping is back. So that was very quick, but still we can improve that performance a little bit. So I will go here to R1, I will start the device again, and it's simply going to remain as slave or backup. But if we want to have that message coming more often, then we can simply decrease that value. So for example, I can say I will be sending this every 300 milliseconds. Something important is that this value must match in both ends. So I will set this 0.3 seconds, basically is equivalent to 300 milliseconds. And now I will go to the other device and I will do exactly the same. So I'm going to set the same value. Now we have here R1 is the master. So let's repeat that process. So I will come to R1, then system, shutdown, yes. And we can see that now this lost only one message. This is how VRRP works. It's important to mention that the configuration on the routers won't be synchronized. That's something that we need to replicate, or we have to use scripts to be able to replicate the configuration from the master into the slave. So the idea now is that the backup device is going to be mirroring the configuration in the master device. I hope that this video has been informative for you, and I see you on the next one. Thank you.